Hello friends, how are you? Welcome to my YouTube channel. Today we will discuss and understand the area of some two-dimensional regular figures and try to understand their formulas. So the first we will try to understand the square. Square basically is a two-dimensional figure where length and breadth is same. So that has only sides. Side suppose A and another side is also A, and its area can be found out by making squares. I already had explained in my previous video. So if anybody is seeing this video for the first time, I advise you to please see my previous video on the concept of area. So in case of a square, we know that this is a particular square. Okay, so the area of this particular whole square, the whole bigger square, can be found out by counting the number of smaller squares. Okay, where I already explained in my previous video that if suppose this is a particular segment of a square whose side is of 1 centimeter each, and its area would be 1 centimeter square, or that is the area of a square, right? Area of a square whose side is only 1 centimeter in length. So here in this case, that is 3 centimeter, and that also is 3 centimeter, and the number of squares is 9. So area in this case is 9 centimeter square, right? Because there are 9 number of squares available in this bigger square. And so area of a square in this case can be found out by multiplying the sides of a square. So area of a square is basically side into side. Okay, so side here is A into A, so that can be written as A square, and units square, where unit is basically the unit in which the length of the side is calculated. Suppose this length is in centimeter, so that unit would be in centimeter square. If this is in meter, then in that case area of a square would be measured in meter square. Okay, like in this case, if it is 3 centimeter, so that would be 9 centimeter square, and if it would have been, suppose, is 9 meter, so both side 9 meter, so that would be 81 meter square. Okay, so it means unit square means the unit will be in terms of that length in which side of the square is measured. If it is in centimeter, that would be centimeter square. If it is in meter, that would be in meter square. So let us take another example. Suppose now the second figure is not a square, but suppose that is a rectangle. Okay, so rectangle we know is a regular figure, two-dimensional figure, but here in this case sides are not equal. So one of the side is longer than the other, so the longer side is called length. Okay, whereas the shorter side is a breadth. So here in this case, again, that can be calculated by counting the number of small squares available, like in this case this way. Okay, suppose its side is 4 centimeter and that length is 1, 2, 3, 7 centimeter. Okay, so again the number of square can be counted out. That will be 28 number of squares available here. So the area of that rectangle would be 28 centimeter square. So that can be found out by just multiplying the length and the breadth. So area of rectangle here in that case would be length into breadth. Okay, so that would be L into B, and again units square. The concept is same. If it is in centimeter, that would be in centimeter square. If length is in meter, that would be in meter square. Okay, so now we'll try to understand the next figure. Next regular simple figure is a right angle triangle. Okay, right angle triangle. So right angle triangle is basically a triangle whose one of the side or one of the angle is of 90 degrees. Suppose this length is B, that is base, and that is suppose is the perpendicular, if is suppose is H. Okay, and that is a 90 degree angle. So you can see here in this case that this right angle triangle basically is half of a rectangle, and we already know that if it is length suppose is B and height breadth is suppose is H, so the area of this rectangle, suppose rectangle was ABCD, right, and ACD is the right angle triangle. So obviously right angle triangle's area in that case would be half of the area of ABCD, which is the rectangle. So here in this case, area of right angle triangle would be half of area of the rectangle ABCD. Okay, and we know that the area is length into breadth. So length here in this case is B, which is the base, and breadth is height, which is the perpendicular. So that would be 1 by 2. B is base into height, okay, or base into perpendicular. So obviously unit would be in unit square. Again, same concept. It is in centimeter square if this length is in centimeter, and if it is in meter, if it is this in meter, the unit would be in meter square. So basically whatever the unit you take, whether it is in centimeter, meter, kilometer, or any millimeter, anything, so that would be square. Okay. So let us take another example. So let us take any regular figure. Okay, suppose it's an equilateral triangle. So equilateral triangle basically is a triangle like this whose all sides are equal, right? All sides are equal. Means if this side is A, that side is also A, and that side is also A. Okay, so the length is same everywhere. So what we will do here is we will just draw perpendicular from one of the vertices. Suppose this is one of the vertices A, there is B, and that is C. So the angle made by this perpendicular on the opposite sides, which is BC, is 90 degree. So this basically is a right angle triangle. Suppose ABD is a right angle triangle, and this whole equilateral triangle ABC is basically has two right angle triangle, ABD and ADC. Okay, so here in this case, equilateral area of equilateral triangle ABC would be double of area of right angle triangle. Suppose ABD. Okay. Now the question that arises here is, what is the area of this thing? So that is 1 by 2 base into height. Base here in this case is this one, because this is a right angle triangle whose base is B. Okay, so this base has a length, if it is A, so that would be A by 2, and that is the A. So base is A by 2 and perpendicular is AD basically. Okay, so we have to calculate what this AD is. Okay, so AD can be calculated by using Pythagoras theorem. Okay, so what is the Pythagoras theorem? Pythagoras theorem says that the hypotenuse square is base square plus perpendicular square. So here in that ABD triangle, hypotenuse is AB, so AB is square, perpendicular is AD is square, and base is DB, that is square. So just by calculating you can know, you will find out that AB is basically small a, that is a square, and AD is suppose is h, so that you have to find out, that is h square, and that BD is basically a by 2, so a by 2 is square. Okay, so just you can calculate it here. So a square is equal to h square plus, if you square a by 2, so that would be square a square by 4. So here in this case, a square minus a square by 4 would be your h square. So that would be, if you take LCM, that would be 3a square by 4 equal to h square. So h would be root 3 by 2 into a. So if you take the square root, you take here, that would be square root, so this 3 would be in square root of 3, 4 become 2, and a square would become a. Okay, so that would be the height of the triangle. So now the question arises that what is the area of right angle triangle? So if the area of triangle ABC, here in this case would be double of area of triangle ABD. Okay, so ABD ka, that would be twice of ABD area. ABD's area is this much. ABD area is 1 by 2, base is a by 2, and AD is basically h. We already calculated this AD, h we have calculated just right now, that will be root 3 by 2 of a. Okay, so you can write root 3 by 2 of a, that is in place of AD from here. Okay, that is very simple. So that will, you would make out this thing would be 1 by 8, 2 to the 4, 4 to the 8, 8 root 3, so basically root 3 by 8 into a square. Okay, so that would be the area of this right angle triangle. So you, just straightforward, you can write it here. So that would be root 3 by 8 into a square. So that would cancel out. So that would be root 3 by 4 into a square. Okay, so that basically is the area of an equilateral triangle. So now let us try to do another question and try to understand to calculate the area of another triangle. So suppose now take an isosceles triangle whose two sides are equal and perpendicular to each other. So that basically is a right angle isosceles triangle. So let us take right angle isosceles triangle. So this is of that shape. It simply means is that the two sides are equal and are at an angle of 90 degrees. So suppose that side is A, and again this side is also A. So just by seeing, it is apparent very clearly, you can see that that basically is the half portion of a square, right? So here in this case, area would be half of the area of square ABCD. So the area, half of the area of ABCD. Okay, so the area in this case of ABCD is side into side, which is A into A. So, and that would be in units square. So area here in this case would be half of A square, and of course unit square, where this would depend whether it is centimeter square or meter square or anything, whatever the unit is. Okay, so just take another example. Suppose now we'll take another triangle which is not a regular one. Suppose this is another triangle whose all sides are different sides. So suppose that side is suppose if this is angle B, the opposite side of that angle is small b, suppose, okay, and if it is A, so the opposite side is A, and if it is C, so the opposite side is the C. Okay, so that is the nomenclature we use in maths for denoting the sides. So suppose we draw a perpendicular here in this case, suppose whose length is h, okay, that is a perpendicular. So basically there are two triangles. One of the triangle is BCD and other is BDA. Okay, so here in this case, area of ABC would be equal to the area of BCD plus area of another triangle which is BDA. Okay, and we already know that the area of a right angle triangle, because BCD is a right angle triangle, okay, is half base into height. Base here in this case, if suppose this is x, length of AD is x, and the whole side is B, so this length would be B minus x. Okay, so for BCD, base is this much, which is B minus x. Okay, very simple, and height is h. Similarly, for triangle BDA, the perpendicular of course is h and base is x, so this much is the distance, which is x, and perpendicular is h. So by just comparing, you can see that 1 by 2 and h can be taken as common, so the remaining part would be B minus x from this side, and here plus x would remain. So obviously this plus x and minus x would cancel out, so the area of this whole triangle would be 1 by 2 B and h. And of course we know that B is base, okay, and h is the perpendicular height of the perpendicular, right? And of course area is always calculated as square of the unit we had used. Okay, so there is another way of calculating the area of a triangle whose sides are different from each other. Okay, so let us take another example. Suppose we now has a parallelogram, so just calculate area of a parallelogram. So suppose parallelogram is of this kind of a shape, okay, and this is the diagonal we have used. So suppose ABCD is the parallelogram. Parallelogram basically is a four sided figure, okay, where opposite sides are parallel to each other. Suppose these side and this side are parallel, likewise this side these parallel sides are parallel to each other. Okay, so obviously automatically opposite sides would become equal in length, whereas angle is not 90 degree. Like in case of a rectangle, all four sides or the angle made by sides are 90 degree, but here the two opposite angles are obtuse and the other two would be acute, less than 90 degree, and other would be about 90 degree. So now our task here is to find the area of parallelogram which is ABCD. So area here in this case ABCD, parallelogram ABCD is equal to the sum of area of triangle ABD, area of triangle ABD, plus area of triangle this one which is BCD. Okay, So let us draw a perpendicular from this side whose length is h1 and another perpendicular is suppose h2. Okay. So that is very simple. We already have calculated. So if suppose the perpendicular is given on and the diagonal is given, base is given, so the area of this triangle is half base into height, and base is basically here is BD, which is the base. Base is the side on which perpendicular is lying, okay, or falling. So from point A, perpendicular H1 is falling on BD. So that is base. BD is base, and perpendicular here is H1. Similarly, in another triangle, base again is same BD, because perpendicular from C is falling on BD. So base again is BD, and perpendicular is H2. So you can take BD and 1 by 2 common from here. So 1 by 2 into BD into you have taken common. So here is H1 plus H2. These are the two perpendiculars which is remaining, and of course unit square. So suppose if BD side diagonal is of length, suppose B, so that would be B into H1 plus H2, and that is unit square. Okay. So the same concept would be used to find the area of some other figure also. So suppose now take an example of a rhombus. So area of a rhombus. So rhombus basically just an analogous of the parallelogram, as parallelogram is relating to the rectangle. In the same way, rhombus is relating to the square. So basically, rhombus has all four sides equal, okay, and they are parallel, but they are not perpendicular, as it was the case for a square. Okay. So suppose there is a parallelogram whose these opposite sides are parallel, and of course that is same in length. Okay. So suppose we, but the important another important thing in rhombus, which it actually follows, is that the opposite diagonals. Okay. Suppose A, B, C, D is the side of the rhombus. So diagonal are BD and AC. So these cut each other or intersect at a 90 degree angle. Suppose this diagonal from B to D, suppose is of length D1. So they will intersect at the middle. Okay. So from, suppose that middle point is O. So OD would be D1 by 2, and similarly that would be D1 by 2. Okay. Likewise, suppose if this side, this diagonal is D2, suppose, so this side would be D2 by 2, and that would be D2 by 2. Okay. And that makes an angle of 90 degree. So there are basically four triangles. One this, another triangle is this, this and this, and these two triangles would have the same length. Likewise, this would be also same area, and these two are equal. All four triangles here in this case makes equal angle. Why so? Because in this case that is D1 by 2 and that is D2 by 2. In this case that is D2 by 2 and that is D1 by 2. So D1 by 2 or D2 by 2 are common in all the four triangles. So suppose let us take this triangle, that is the first triangle, which is a area. Suppose I am interested in finding the area of triangle A, B, O. So that would be base, half base into height, that we know, and base, suppose that is base, so height would be this. So base here is, in this case, is D1 by 2, and height is D2 by 2. If you will apply the same logic, so same kind of area would be for this triangle and the triangle, and all four triangles would have the same area. Okay. So the area of rhombus here in this case, so the area of rhombus ABCD basically would be 4 times of the area of this triangle. Okay. So area of triangle ABO, so that would be 4 times of area of triangle this one, and that is 1 by 8 D1 by D2. So that would be 1 by 2 D1 by 2 D2. So you can say the area of a rhombus, of course the unit would be unit square, would be 1 by 2 D1 by D2. So basically D1 is the length of first diagonal, diagonal 1 and that is diagonal 2. Okay, and that is unit square. So that is also very simple. So we applied the same logic we had applied in our previous examples. So let us take another example, and then example here in this case is a trapezium. Okay, so trapezium, suppose basically is of that kind of a shape. So trapezium basically of this much of a kind of a shape. So okay, that's simple, very simple. So just suppose for simplicity we have taken this as a trapezium. That is also a trapezium. Trapezium basically is a four-sided figure in which two sides are parallel to each other. Opposite sides are parallel to each other, and they need not be equal in length. So here in this case, suppose ABCD, AB and CD is parallel. Okay, and suppose they are separated by a distance of h. So here in this case we can find out the area. So area, that is very simple. Suppose if you will draw a perpendicular here, so if it is h, BC is h and that point is E, so that would also be h. AE is also h. So area of this is basically is a rectangle. So if that is the base, okay, and the base suppose has a length of b, and this length suppose is x, so this would be b minus x. Okay, so obviously area would be length into breadth. Here in this case, if it is a square rectangle, so ABCE, if suppose is a rectangle, so area of rectangle rectangle ABCE here in this case would be length into breadth. So length here is AB, or you can say EC, which is b minus x, and breadth is this one, which is h. Okay, and you can say that area of another figure, which is this is just a triangle. So area of a triangle AED, you can calculate ADE. So that is base into height, 1 by 2, base into height, and base is here in this case is x, BE is x, and height is h. So the area can be found out. Suppose trapezium has an area basically is the sum of area of ABCE, which is the rectangle, this one, and area of triangle, this one, so it's ADE. Okay, so here in this case this area is b minus x into h, and here the area is 1 by 2 x into h. If you will take h common here in this case, and suppose so if you will take h common, so that would be b minus x plus half of x. Okay, so that would be if you just take common. Okay, suppose I'm taking 2 common here. So that would be you can take 2 common, suppose 2 and h I have already taken common. So there will be 2 times of b minus 2 times of x plus of x. Okay, so that would be my 2. This basically can be written as 2b minus x, which is nothing but 1 by 2 b plus b minus x. Okay, and suppose this length is a, not a. Let us, if this length is a and that length is also a, okay, and this supposes if it whole length is b, so that would be b minus a. Okay, that would be b minus a if it is b, right? Simple. So let us change slightly. So the area of this triangle, rectangle here in this case would be length into breadth, which is h into a, and this would be 1 by 2 base into height. So here in this triangle is base is this much, b minus a, and that is height h. So let us take this here. So here is the area would be a into h plus 1 by 2, that would be b minus a into h. So again let us take h common, 1 by 2 of h we are taking common, so that would become 2a plus b minus a. So a would cancel out, 1 by 2 into h, a plus b would remain. Okay, so that is nothing but 1 by 2. H is height, okay, and that is the sum of the parallel sides. So basically a and b are the sides, parallel sides a and b, so that basically is the sum of a, and of course the unit square. So that is a simplified version. It is not necessary that that would be of perpendiculars. Okay, so suppose take a general trapezium. So let us take this as a general trapezium, okay, whose sides, again for simplicity, suppose take as a general trapezium, okay, and whose sides suppose is this much, which is b, and this suppose is the a. Okay, so for simplicity, if it is a, so up to this point that would be a. Okay, let us take that is a, and height is suppose perpendicular is h, and so this length and this length would become, suppose this length is x then. So what is this length then? That would be what? That would length be how much it is. We know that the total length is b, so that should be equal to sum of x plus a into sum this length. Suppose this length is y. We don't know what this length is, y. So y can be calculated. So y would be b minus a minus x. So that would be the length. So this would be basically b minus a minus x. So now you can calculate what is the total area. So again, now here in this case there are three areas, a1, this figure has a2, and that figure is a3. Again area would be same, formula would come out to be the same again. Okay, so the area a1 here in this case is that basically is a rectangle, so a into h. Area a2 is a triangle, 1 by 2 base into height. Base here is this much, b minus a minus x, and height is h. Okay, that is h. And the area a3 is again 1 by 2 base into height. So there is a triangle, base is x and height is h. So for finding the total area of a trapezium, you just has to add all these three figures. So the total area of trapezium ABCD would be 1 by 2, A1, area of A1, area of A2, area of A3. Okay, so area of A1 is this much, A into H. Area of A2 is 1 by 2, B minus A minus X into H. And of C is 1 by 2, X into H. So you can take 1 by 2 H common here. So A 1 by 2 A, if you will take H, you will take common, then that would become 2A. 1 by 2 and H you will take common, so that would be B minus A minus X. And we have taken 1 by 2 H to X would remain, so X would cancel out. So that would be 1 by 2 H into 2A, and that would be plus B minus A, and X is also already cancelled out, so that would be 1 by 2 H into A plus B. So that would make A, and there is B already. So again same. Okay, so likewise we can calculate the area of regular figures whose sides are closed and two-dimensional in shape. So that's it. Now I'm signing off from here. I hope this video will be very helpful to understand and remember the area of some of the two-dimensional regular figures. To understand the concept of an area, I request all my viewers to please see my previous video, which is relating to the introduction of the concept of area. If you like the video, please click on the like button. If you like the channel, You can also subscribe my channel. Thank you for watching the video. Thank you very much.